Hi, my name is Patrick Dog. I work my final project as civil engineer on the flood hazard mapping of the Kalb River using GIS, HMS, and HGRAS, and we had the study of the hydrologic and hydraulic study. As we know, Nahr al-Kalb is one of the main estuaries in Lebanon. It's very important, and it has at the lowest part a flood hazard area, according to the Lebanese Water and Energy Ministry. No previous GIS flood analysis was carried in that area, and the flood hazard mapping during the rainfall, the high intensity rainfall, helps forecast the maximum height the water level can achieve. My research aim was, as I said, to conduct a GIS flood hazard mapping analysis for the Nahr al-Kalb. The research objectives were to estimate the peak discharge during the highest rainfall and to generate water surface profile of Nahr al-Kalb. So Nahr al-Kalb is located in Mount Lebanon Governorate. The river flows from the east to the west. It's the area, the basin area is 259 kilometers square. 56.5% lies in Kisrwan and 43.5% lies in Al Matan, Gaza. The highest point of the catchment is Mount Sannin. Multiple structures affect the flow regime. They are Shabruh Dam that was built in 2007 in Kisrwan, the Ata Dam, which is under construction in the Matan area, and Nahr al-Kalb interchange, which was studied in 1984 by GCOM. So we started using ARC Hydro tools provided by ASRI, HGEO-HMS, HGEO-RAS, and we used for hydrological modeling and for extracting the geometric data for the watershed. We started by the intensity duration frequency. We had the data from Jaltoon Water Station for the duration from September 2010 till February 2018. Then we had the IDF curves that were developed according to the EV distribution approach, illustrated by the Gumbel type 1 distribution, and the vast regression method was the power method with an R square of 0.9658. Then we had the rainfall distribution, which the type 1A is the best rainfall storm distribution for Lebanon that suits Lebanon for the 24-hour storm, and we work on the 100-year event. As GIS, we started by generating the DM model, then we used all the ARC Hydro tools to generate the watershed with all the reaches and joints available in that watershed. Second, we worked on the soil conservation service, the curve number, which is mainly the combination of the land and land use, land cover, and the soil to get the CN grid, which will be used later on per sub-basin to get the hydrological model. Here we have the sub-basin parameters, each junction, the per sub-basin, using HGEO-HMS. We extracted all the data for the CN for each basin, and then we used them in the HMS to get the peak flow. Here is the peak discharge for the 100-year event 24-hour storm. We have it on the 9.75 hours from the first droplet from the starting point we have the peak. It's the total volume of rainfall excess is 107.24 millimeter, and the last droplet of water withdrew from the outreach was on the 4.5 hours of the end of the storm. You can see the water surface profile using HACRAS. It exceeded the alarming height rate of height of 4 meter for the river world protection. The peak water flow surface we reached is around 12.1 meters. We're talking about the 100-year event, which is the most extreme rainfall that we can get. And at the outlet, the flow was subcritical, having a maximum water height of 5.81 meters. As conclusion, as I said, the peak rainfall discharge value was 882 meter cube per second. The water level reached at the peak discharge was 12.1 meter, and at the outlet 5.81 meter. The flow regime of the channel was supercritical for the steep slopes on the river outstream. The hydraulic jumps occurred caused by the variation of flow from supercritical to subcritical flow. The flow regime occurred mostly at the mouth of the watershed where the slope is mild. The height of the river protection walls should be increased. The restaurants along the river sides are unhazarded due to the flood. In the future, we should use a higher resolution DIM for the floodplain analysis, since we work on the hydrologic mainly and the hydraulic profiles, and we should add the structures and the obstructions for better analysis. Thank you.
Nice talk.